Continuing to find derivatives on this worksheet, we look at problem 10, where we have a fraction. If you have a function in the numerator and a function in the denominator, you're going to want to use the quotient rule. And the quotient rule looks like this. So if you have a function that has a top and a bottom, two functions, the derivative of that function will be the bottom, b of x, times the derivative of the top function, minus the top function times the derivative of the bottom function over the bottom function squared. So you see that as we look at problem 10, we took the bottom, 2x plus 3, times the derivative of the top, which would just be the 3, and then subtracted the top, the 3x minus 4, times the derivative of the bottom, which would just be the 2, all over the bottom squared. When we distribute this out, we get 3 times 2x is 6x, 3 times 3 is 9, 2 times 3x is going to give us a negative 6x, and 2 times a negative 4 is a negative 8, but because it's being subtracted, it's a positive 8. Then my negative 6 and my positive 6x cancel, leaving us with our simplified answer, 17 over 2x plus 3 squared. Now, we typically don't multiply the bottom out. We leave it as 2x plus 3 squared. On number 11, we'll need to use the product rule, which we remember is, let's just do it, the first times the derivative of the second. So if you take the first, 3x times the derivative of the second, the derivative of e to the x is simply e to the x. And then plus the second e to the x times the derivative of the first, 3, we just get this. Cleaning this up a little bit, we have 3x e to the x, and then we move the coefficient in front, so plus 3e to the x. Noticing that both of these terms have a 3 and an e to the x in it, you can factor that out and just have x plus 1 left. But either of those is a perfectly fine answer. On number 12, once again, we have the quotient rule. So the quotient rule tells us to use the bottom here, 1 plus natural log of x, times the derivative of the top, which would just be 2, minus the top, 2x, times the derivative of 1 plus natural log of x, which is the bottom. The 1 will become a 0, and the derivative of natural log of x is 1 over x. Now this looks complicated, but then we recognize that when we multiply 2x times 1 over x, we're simply just going to get 2 because the x's will cancel. And here, if we distribute the 2, we'll have 2 plus 2 natural log of x. Now the positive 2 and the negative 2 cancel, leaving us just with 2 natural log of x over that 1 minus the natural log of x squared, which is that denominator squared. On number 13, once again, we're going to use the product rule, which tells you to take the first times the derivative of the second plus the second times the derivative of the first. So here we have the first times the derivative of e to the x, which is e to the x, and then plus the second, which is that e to the x, times the derivative of the first. Now the derivative of the first will be 1 minus 2x, because we'll take the derivative of each term. The derivative of 1 is 0. The derivative of x is 1. The derivative of x squared is 2x, and we'll be subtracting it. So here we have the derivative of the first. We would notice at this point that you can factor an e to the x out of both of these terms, which comes out front. And then what's left inside the big parentheses would be the 1 plus x minus x squared, and then plus the 1 minus 2x. That's here. And that will clean up when you add like terms to just 2 minus x squared. So that's a nice way to write the answer. If we look at problem 14 and 15, we need to use the chain rule. So let's write the chain rule out down here. The chain rule states that if you have an outside and an inside function, let's call the outside function t of x. And then you have an inside function, and I'm going to go ahead and call that n of x for inside. If you have a function like this, the way you take the derivative is to take the derivative of the outside function, leaving the inside function the same. So that inside function, we're just going to leave it. Then we multiply that by the derivative of the inside function. That's our chain rule. So let's see how that applies here. We can see here that we have an inside and an outside function, with my inside function being the w squared plus 8. Oh, I should have left that blue. Anyway, here's my inside function, and the outside function is to the 1/2 power. So taking our derivative, using our chain rule, the derivative of anything to the 1/2 power would be 1/2 times the inside function to the negative 1/2. That's this part here. I just did that in this stage, that part there. Then the derivative of the inside function is the 2w. Simplifying this, you could recognize that the 2 in the denominator and the 2 that's not in a denominator but in a numerator would cancel, leaving us just a w like this, and then this w squared plus 8 to the negative 1/2 power could be written in the denominator or could be written as a square root. You could also write this as w times w squared plus 8 to the negative 1/2, and that would be fine as well. Looking at 15, again, we have our inside function, which is the 4 minus x squared, and the outside function, which is natural log of x. A lot of people make the mistake of thinking that this is a product rule, but it isn't. This is what we call the argument of our natural log. So when we take its derivative, the derivative of natural log is to write 1 over the derivative of the inside function, which we just did here. Then we take, or I'm sorry, just 1 over the inside function. Then we take the derivative of the inside function and we multiply that times the derivative of the outside function, leaving us with a negative 2x over 4 minus x squared. Well, if you needed those explanations, I hope that was helpful, and we'll do more with this later. Thanks for watching.